welcome to another problem session. So this is a kind of interesting problem, and if you set it up correctly, it's not that difficult to do. Okay. All right. So you get a pen. Let's get a black ink. All right. All right. So you have a projectile. I read this problem already, so I can try to draw a diagram for what it says. So, and there is a wall here, and it hits the wall somewhere. It's not total parabola, it's the wall. Initially it is some V0 and some angle theta 0 with the horizontal. So this is the horizontal. So let's call it X, let's call it Y, and there's the mass is 200 grams. So V0 is 270 meter per second. Theta 0 is 60 degrees. Mass is 270 gram. So there's actually a viscous force on it. So some time t is over here. The velocity is this way. And if you look at the forces on this, of course there's a gravity this way, and there is exactly opposite to that is this viscous force F minus CV, and C is greater than 0. C is given actually 0.1 kilogram per second. That's unit should be just because this has to be unit of force. So there has to be one more to make it kind of unit of acceleration, right? Mass times acceleration will be the unit of force. And it tells you this is instantaneous velocity. So you should think of this as V, this vector. That's the vector at time t. Instantaneous at that instant. At that instant t. So time here is 2 seconds. So it's going to hit at some, the coordinate of that is some x and y. So this x is 0 here. That's the x. So we are supposed to find what value of x. So find x in meter. We're supposed to use this Euler E, which is irrational, but just use 2.7. But you know it goes on forever, but just clip it here. All right. So how do you handle, so you can make use of what will be, you know, if you just jump the gun and use regular projectile formulas from memory, you'll be totally wrong. Okay, because regular projectile motion does not have this. So ideal projectile motion, if at time t, if you look at this is the only force. That's the only force. Here the situation is different. You have two different forces. So we're going to have to start out with writing equation of motion. Okay. So at this instance, I'm going to write no, let me erase that. I'm going to write equation motion in a vector form, and this will be j hat, and this will be I hat directions. If you look at here, at this instant, mass times acceleration is equal to minus c v vector, which is leave it as a, we're going to break it up into its component in a minute, and minus mg j hat. So now if you write down components, write say v equals to vx I hat plus vy j hat into that makes it d I hat dt 0, and so is d j hat dt, because they don't depend on time. Cartesian unit vectors don't depend on time. So we are we can separate this m dvx dt I hat plus m dvy dt j hat, and there will be x and y component of this guy. So let's write minus cvx I hat minus cvy plus mg j hat. So you'll have two different equations, but my question is asking only to look and they don't depend on each other. So let's separate out, and you see that we only have to do with one of those. So separate it out. Minus cvx doesn't depend on y at all, and mdvy dt is minus c vy minus mg, doesn't depend on vx, so they are uncoupled. They are called uncoupled, so they can be solved separately. So yeah, this problem, because I just need to find x and don't need to find y where it hit the wall, so we just can actually do with this. So this one it's very easy to solve, and you should have solved this many times before coming to this class. And I'm just going to write the answer: vx at time t minus vx at time 0 equals to e to the power times e to the power minus c over m t. So take m from here, put over m over here. Actually take m from here and cancel this out. So that's the way we're going to deal with this one too later, but you don't need this for solving this problem. So this is the answer. So vx sub 0 will come from this. We're given that you have a v0 theta 0, and this is I hat vx at 0 time equal to v0 cosine theta 0. If you want to put values here, that's fine. Okay. I'm going to go ahead and put the values because actually not that difficult. So you have it, this is 270, and cosine 60 degrees is 270 over 2. Okay. You can put it like this, or this will be 135. I personally think putting numbers here actually makes me confused, and I lose track of what the concept is. So most I'm going to do is just make this guy just a new symbol v0x, and it just leave this. I'll just make sure that this unit should be 1 over time. So we'll just look at the units. C is kilogram over second, and this is kilogram. So this is 1 over second, which will multiply by t, and this whole thing should be unitless. So far, that means I've done so far correctly. Okay, so now we are here. So, but we need to get x. So, but this is left side is dx dt, and right side is v0x. This is constant, e to the minus c over mt, and there's no x here, so just dt, bring dt and integrate it. So x of t minus x at 0 time equal to v0x 0 to t e to the minus c over mt dt. Of course, this is going to come down like this, v0 of x e to the c over m t over minus c over m 0 to t. So you can see you can bring this minus up front here. Always a good idea, because you're going to get lost pretty soon if you don't bring that. So this m over c minus c over m t minus m over c times 1. When t equal to 0, it becomes 1. And you can see this is bigger than that, and so m over c v0 of x 1 minus e to the power c over mt. So, but this is this is equal to 0 because we were at the origin. So x of t and we can use this in our given values to figure out what x is. So x of t at t equals to 2 seconds. Okay, we need c over m and m over c. So let's compute c over m. C is 0.1 and m is 270. C is 0.1, m is 200, not 270, 200. The reason I started look is because this thing, it was coming out in a very weird number. So this is 1 over 2. So m is 270 grams, which will be in the kilogram, because this guy is in kilograms, so I should make it 0.2 kilogram. So now, remember I was telling you, when you put the numbers, you have to be extremely careful. Our m over c is just 2. So it's 2 times 271, 1 minus e to the power c over m is half times 2. So this is 2 times 271 270 v0x cosine 60 degrees 2 times 270 half 1 minus 1 over e, and I left it there like because I know it's going to cancel out that guy because e was supposed to be 0.2, I mean 2.7 for us. So this will just become e minus 1, and so e, so it is 2 cancel out, and you have a 270, e is 2.7, 2.7 minus 1, so this makes it 100, and this is 1.7, 1.7 times 100 is 170 meter. That's the answer. So the answer will be 170 meters. Yeah, be careful. I mean, when you work in symbols, it's easy to check your work, but when the moment you start to put numbers, you can really mess it up. You know, you can easily mess it up. Like I was doing here. Okay, so the problem is done, but you know, suppose you had ended up with having to deal with the y part. Okay, what will you do? How would you handle that? So here's a dvy dt. So this is just extra. It's just extra. It's not part of this problem. And we have minus c over m vy minus g. Okay. So one way to do it is somehow absorb this. So suppose I do c over m and make it vy like that way, plus mg over c, like this, right? So you can define this as a u. Okay, you'll say vy plus mg over c. I hope I'm not making a mistake here. Then du dt will be dy dt vy dt and plus 0. So this side doesn't change, so you have a du dt is equal to minus c over m u. Now this is the same as the x equation, so this one we already know. U at t is u at t0 e to the power minus c over mt. So you can write down what u of t is, just vy at t plus mg over c, and u0 will be vy at 0 plus mg over c times e to the minus c over mt. Okay. And then you can bring this on the other side, mg over c, and this whole thing is constant, this is constant, so this will be dy dt will be just integrate this whole thing dt. This will be dy dt, this will y at t and y0 will just integrate this whole thing with dt, because that's how I'll handle it. The y was needed, but it's not needed. Okay, so that's it. We're gonna we're done with this problem. I'm going to see you in another problem. Bye.